Hey y'all, Bunny Tech Gal here, and I am bringing you a new fancy little channel that is going to dive into what coding and programming and computer science looks like at a beginning stage. So I teach middle school and high school computer science courses through Project Lead the Way over in the southeast corner of the United States, which is why I sound a little bit twangy. And I am going to be sharing out all things awesome and beautiful that occur within the three Project Lead the Way courses that I teach, that we're going to be connecting to people that are out there in the industry, working, whether it be with streaming or game design or any kind of creation of programs and apps and all of that kind of jazz. And then we're also going to be sharing out all the cool, fun, awesome, amazing projects that we are creating. All right, so today I'm going to take you into computer science for innovators and makers, and this is designed for the middle school level. And it is probably the first or close to the first time that some of these kiddos would be playing around with any kind of code. And this class primarily is going to be working with coding microbits, which are really, really neat. And it's a really cool thing to add all the way down to like the level of sixth graders. In my school, I teach this to seventh and eighth graders. So within this class, you're going to see a lot of different codes and projects that go along with the microbit, but you're also learning a lot of good life skills as far as computer science goes, with creating algorithms, using flowcharts, being able to understand the idea of using elbow partners and paired programming. So I think that is really, really awesome and essential for students that are that young to go ahead and start learning. And I really wish that this existed 100 years ago when I was in middle school and high school. But alas, that is not the case. We had old IBM computers. This is some of the stuff that they will be working with. And then here it has the standard alignments that I will share in just a moment. And we start out this course with speaking about the engineering design process, which is another thing that is extremely critical for computer science students to know, and then also just in general in life. That not everything always works perfectly when you are going through a series or steps of things, and you have to go back and not reinvent the wheel, but go back and relook at some things. And we do that super often. We do use pair programming, even with COVID cooties right now, which makes that a little bit confusing. We connect digitally through a Google Meet so that we can pair program from across the room. And we are going to be using a lot of this website that is by Microbit. And then we will be creating flowcharts, and the website that we use for that primarily is draw.io. All right, so within this curriculum, you're going to see some really cool projects that the kids are going to be able to do. And then we're also going to be sharing out videos of them actually teaching other students to complete these exact same coding assignments that we will be connecting across, definitely across the United States, and hopefully into different countries that we will broadcast to, maybe a classroom in Italy, that we will be able to teach those students how to do this same code. Another thing that we do here in the Bunny Tech Nest is that we also try to find rock stars out there in the streaming community, working with all things tech, and we're going to be highlighting them, which is why in the background right now I mentioned Italy, because we are highlighting a musician that we have located that is in Italy. And we connect to him through Twitch and talk to him about what it looks like over in Italy to be using technology and how that's different here in the United States. And then we also talk to him about music, because who doesn't want to talk about music? So if you want to find him on Twitch, his name is Victor Loved. All right, so thank you guys so much for stopping by and checking out our videos. And as I always tell the kids, we will catch you on the flip side. So peace out. All right. Hey there, nestlings, and happy whatever day it is. when you guys are checking out this video. For most of you guys, it is probably going to be Thursday, and it will be December the 10th if you were looking at this on Thursday. So welcome back, and let's go ahead and dive into our CSIM activity 1.2. We started this on the previous number in Google Classroom, and now we're going to be finishing that up. So in assignment number 23, we went in. If you forgot how to get there, you go in on your landing page, and then you're going to go down to lesson 1. And then we're going to specifically be going to lesson 1.2, as you see right over here. All right, so you also are going to need to have your digital notebook brought up. All right, so what I would do is I would go right over here. I would open up a tab, and I would go down to my drive. Remember, I have desperately asked you to take and make sure you save this in a location that you can get back to very quickly, also known as bookmark it. So I would already have that brought up. And we also have some key terms that we need to add right now as well. All right, I am just going to use Dawson's as an example. All right, so the first thing to mention is yesterday or day before when you were working on activity 1.2, you very well may have not already thought about those key terms. But remember, at the end of every single one of these activities, you are going to have a short skills-based quiz that counts as a test grade. So I really need you guys to keep a list of those vocabulary terms. So when you are on activity 1.2, any of these that are in orange are ones that you're going to want to save. I have already done that for you. So if you go to this document that I've already given you guys access to, that is entitled Key Terms, I believe, you will already see those terms there for you, and you will just be able to add them to the one that you already created. All right, so let's go ahead and start looking at a little bit of a review from yesterday. All right, so right here, I am going to drag this over here so we can see it a little bit bigger. All right, so right here, I went in and added a little bit of a key so that we could talk through and make sure you understand some of the stuff that we were looking at on the previous assignment. And we were focusing in this assignment primarily on our flowcharts and what those are going to look like and how that is related to an algorithm. Also want to mention we are highlighting our Twitch artist. Today is the musician from Italy that fourth period got to connect with, Victor Loved. So he is currently playing some of his original songs, which is really rad. All right, so now let's take a look right here. I have just a screenshot reminding you that you need to make sure to have that. All right, so now in the previous assignment, number 23, you very well may have had some of these misconceptions, and that just means coming into this assignment, there may have been something that you thought was a thing or you thought was true, and it very well may not be. So we've got those there. You don't just sit there and press a button and then a code just like magically pops up somewhere. You have to actually like write the back end of that, and that's why in the last assignment we were talking about even the Tesla vehicles that are autonomous now, they have to have somebody to have sat down and created all of that code. And heck, if you're even talking about turning the microwave on, the microwave has to have coding to be able to turn on. All right. Pre-planning using algorithms and flowchart is a waste of time. Yeah, it's not a waste of time, and we're going to be doing it. It may seem like it's very bobo and basic and very easy to add in some shapes and move it around and add colors and words and whatever, but I promise, it is very, very, very helpful. All right, algorithms are all linear. No, that is not the case, because in every single assignment, we're going to have a what if scenario of a conditional statement that we get to somewhere, and we have to say, all right, well, what happens if this is true? What happens if this isn't true? And then you can move on after that. So everything is not linear. In fact, I'm even going to jump far enough to say nothing is linear. Even if I'm asking you to make me a sandwich, you're going to have conditional statements. All right. There's only one algorithm. Nope. No, there's not. There's billions. Computers can think or perform actions independently. No, we do not live in insert robot movie here kind of world, or a robot kind of world yet. Maybe in the future, but right now we do not have artificial intelligence that completely and totally is autonomous and thinks on their own without somebody coding it to do it. So even our little vector robot that we look at on Twitch, on Tyrone's Luck, even that thing has to be controlled by humans. All right, coding is best done as an individual. No, absolutely not. Wrong answer. Coding is absolutely best done with us talking collaboratively and us connecting with our, elbow partners, us pair programming, and then us getting back together as a class. And that's why there are so many people out in the quote real world that are coders, that they connect through streaming or through something like Google Meet that we use every day, that they are all programming together or pair programming. So in the real world, that's a thing. So it makes sense that in the 7th or 8th grade, we're going to be doing the same thing. All right. Then going down, we already went through those beginning questions before we even started the assignment yesterday, so I'm not going to review back over those. But when we got down into talking about an algorithm, and we used the example of brushing your teeth, so even if we're going to be writing a very, very basic algorithm for when you wake up in the morning, your breath smells bad, you need to brush your teeth before you go and insult anybody with your breath or assault anybody with your breath. So right here, we have those questions that you were supposed to be working through in your digital notebook. And so here, you were supposed to create your algorithm. And we just use the example of brushing your teeth. If you chose a different one, I think that is completely and totally fine. All right, so you were supposed to find an elbow partner or a paired programming partner for you to discuss that. If you guys went and found the exact same algorithm, you may not have to rewrite your algorithm. Like if you copy that exact same flow chart, you may not have something that is different to share. So I would ask and see if there's somebody else that has a different one. All right, and then we go down and we start talking about what we can do to make them better. You guys have a place in your digital notebooks that you do that. And then right here, you were supposed to fix your algorithm. All right, so let's skinny up to our notebook really, really quickly. And remember, when you are working on this digital notebook, in this case, it is extremely important for you to not add any slides. All right, so when Dawson wrote his algorithm right there, let's say I was partnered with Dawson and we were pair programming together. We were talking about this assignment. I went in, okay, so he wrote an algorithm for making a sandwich. Very cool. So he's got the flow chart. That's not actually the algorithm, that's the flow chart. That is the graphic that we're going to be using draw.io to create in just a moment. All right, so then right here on this slide, I'm going to make this really big really quickly. All right, so right there, we are on slide number 26. I want you guys to compare them. And that means that you are actually going to figure out what could be written better. And then on slide 28, that is where you start figuring out something that you can do to make that better. All right, so now we are down to your flowcharts. And so really big right here, let's take a look. All right, it says we have some questions there. We've already talked about these in the last assignment, but going down to number 5, right there where it says, what is the difference between a linear and a conditional flow chart? We can be Captain Obvious. We say that linear is linear and conditional is not. But right here, I gave you some more options for your answers. Flow charting is never going to be something that is pretty and works 100% of the time, just like when you are in a science class and you are working on figuring out some kind of hypothesis, you're trying to find some kind of answer, and at the end of it, you have to either prove or disprove your hypothesis. Same thing applies here. Is it going to work every time? No, absolutely not. No way, Jose. All right, so a conditional flow chart is going to be the one that we are mainly going to be focused on. And then after we are done, we will go back and pick up those conclusion questions. All right, so where we left off in our video with the last assignment was working on the algorithms. So I'm going to go back over to where that lives. We've already gone through this piece of the assignment. We've already talked about what it would look like to write an algorithm for it being your turn to set the table. You guys watched this video and you had the stuff that you put in the notebook just now. We talked about why it is absolutely critical and necessary and mandatory for us to use these exact same shapes. So when we go out to draw.io in just a moment, that's exactly what you're going to have to do. We talked about conditional statements. And then right here, this actually is in your notebook as well. All right, so look, going back to your notebook, you see the flow chart. And then this right here, this is slide number 31. You have to take and put all of these things in order. And then that needs to live over here. So all you have to do is take and drag this stuff over. And then right here, we are to where we are going to be creating our flow chart in draw.io. And then right after that, we're going to talk about what it means to create mirror drawings. So now I'm going to default to taking myself off of the screen and putting up just what it looks like to go to draw.io. That is yet another thing that I would say that right now, this very instant, before you forget in 2 seconds, if you were me, then I would go ahead and bookmark it. So you're just going to go to draw.io, and this is already in your notebook on the third slide. All right, so right here is where you are going to go. And right here, you can go and you can save it. All right, cool beans, Daddy-O. I don't think I have said anything that could potentially be misconstrued or be complicated. So I'm going to go ahead and dive into this and start showing you guys what a flowchart looks like. And know that every single assignment, we will be creating a flowchart. Every single assignment, we will write an algorithm. Every single assignment, you will pair program and you will bounce your ideas off of someone else. And very soon, we will be bouncing our ideas off of other people in a different classroom, meaning that they do not go to Death and Preparatory Academy. They go to a completely different school in a different state or a different country. And we'll also be doing tutorials that will be teaching younger students how to do this as well, maybe also possibly in another country. So you guys really need to, just like we spoke about in class yesterday, you really need to become your own advocate and start really, really diving into this stuff and being more passionate about it. All right, so let's go ahead and dive in and let's go. So I need you to open a Chrome tag to draw.io. And when you open it up, we are going to go ahead and take and create a folder on your hard drive. So right here, I'm going to have you click device. And then once you click device, we're going to create a folder on our hard drive that says flowcharts. And for this first one, we're going to create a template, which means we are just going to go and create a blank flowchart, and we're just going to name it just, you can just say CSIM flowchart, you can have in your name, but this is one that we'll go back and edit every single time that we're completing this, which is every assignment. Alrighty, so go ahead and type that in. And then create it. And now you see your entire background of all of the things that you can use. And it is full of some shapes and some words and some arrows that we're going to connect together. So make sure you have this split screened with our project Lead the Way and our notebook so that you know what it is that you need. So now we are going to go and just create this very basic template. And then we will use that one over and over. All of the things you see here are going to be pretty basic, and we're going to be creating a conditional flowchart, which, as you read in our textbook, that means of a what if statement. So now we're just going to need to start going and pulling out all of those shapes that we need. Like this oblong circle right here, that is going to be our begin. So every time you need to have a start or begin, it is going to be this exact same shape. And then we're also going to go in and add text. And the text is the biggest thing that you will be editing on each one of these flowcharts for algorithms. So in this case, we're just going to go in and say either start or begin. Either one is fine. And then however you format these as far as the font, that is completely fine. The color also is up to you. You can make it black, white, and boring, or you can rainbow it. It does not matter. So all of those colors there exist if you want to choose them. Use what you want to. And then we will move it around, place it wherever we want to have it. And depending on what flowchart you're doing, it may need to be smaller. Then I want you to go in and let's go ahead, since we have that shape there, and make it easy for ourselves and Control D and duplicate it to be the end. And you can move it around. Honestly, I would say right now for you just to kind of move it over out of the way. And then we will start playing connect the dots, la 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 la. And next we will need that diamond shape and move it over around to where the start is. Just as before, it is 1,000,000,000% okay if you go in and you change the coloration of it and also the font. All right, so this is our conditional statement, as I said, and we're going to go in and add the text. And since we're just doing a general one right now, let's just say, is this condition true? Or is this right? If you wanted to change the font, I highly suggest that since that was really tiny. Use whichever font you want. And the color here, in Project Lead, the way they use specific colors, but it's fine with me if you use whatever color. If I wanted to use green, that is completely okay. And then we're going to go and we're going to want to connect it to the start. So the easiest way to do that is honestly what I'm doing right now, that you are just going to hover on this start button. And when you kind of hover over both of them, like you're drawing an arrow towards them, then it will pop up an arrow that will make everything a lot easier. And then you can take and move it around however you want to. All right, now we need to go in and add in our two very basic commands. And I would just say, statement 1 and statement 2 for right now. Go in and customize it with the font, the color, whatever jazzy stuff you're about to do to create statement 1. Drag it over until it fits correctly. I would keep it about this size, though I wouldn't make it completely crazy big. And then you're going to want to duplicate that after you customize it, because you're going to need two statements, statement 1 and statement 2, that will be what if it's yes, what if it's no. So I just hit Control D to duplicate. Then let's take and move these bad boys over to each side. All right, so if this statement is true, or if this condition is true, it will go to statement 1. If it is false, it will go to statement 2. So now we need to go in and add text that just says yes, and text that just says no. The yes, go in, and I honestly, just for visual sake, I would make yes a green and use whatever font and size that you want, and then duplicate it with the same formatting. And then I would, for no, just for visual sake, again, I would go in and change that to red, because that's kind of like a universal understood color. All right, then I'm going to take and move them to be as equidistant as possible. I don't want my stuff to look completely and totally insane. And then I'm going to make sure that my statement 1 is close to the yes and my statement 2 is close to the no. And now we're going to connect those. So there is the arrow that you could start editing. And in this case, you see that we are trying to create one that has multiple points. All right, so we connect it down to the first statement. And then you are going to go right there and bring it up, around, and over to connect the yes to it. So we don't want it to completely connect, as in the arrow is pointing to the yes, but we're wanting that area to say yes. All right, all I did was I just duplicated that same arrow and brought it over here to the left, as you see. And then in the middle of it, I am going to drag it upwards towards the no. Once again, to where it doesn't actually connect and have the arrow pointing to the no, but that it is over there. And then take and move your yes and no statement over. So now all we have left to do is add in these last little arrows that will connect the dots between the two statements and our ending or our stop button. Easiest way is the exact same way that we just did the yes and the no, with that arrow that has the multiple points. And the reason I like that one is that it just looks neater. We can go crazy and go bananas if we want to with all of this flowchart stuff, with adding in pictures and graphics and word art. But for right now, since we're using this as a template just to remind ourselves how we complete it, we're just going to keep it as simple as possible, like that KISS method. Keep it simple, silly. Then we are going to need to export it. And I would go up to the file menu and I would always export this and download it as a PNG file. And then I would immediately save it into your Google Drive. So the folder that you just created on your hard drive that is going to say flowcharts, I would also make sure that you have that exact same folder in your Google Drive. And that wraps up that flowchart. All right, now let's try our mirror drawings. So just like in elementary school when you had a dictation test, now we're doing the same with drawing. All right, so the purpose here is for us to be able to communicate effectively, as we are going to be using elbow partners and also pair programming. So we have to be very, very specific with our instructions. The same will go for all of your coding. All right, so if I was to give you some terrible instructions, then you could have these instructions and pretty much just draw everything wherever you wanted to, just kind of willy-nilly all over the place. Because notice I am not being specific about how large the shape has to be or where it has to be, other than just a general location on the screen. And you see there, it didn't even say the center of what. Notice my triangles are completely different sizes because I didn't say anything different. All right, so if you would have done that, what do you think yours would have looked like versus what my idea was? So there's obviously going to be some differences because you are a different person than I am, and you may have understood those directions far, far differently. So now it's your turn. I want you to choose your elbow partner that is semi-close to you, and you guys are going to give each other some instructions, and you're going to, just from those instructions, create the mirror drawing. And I want you guys to do this in draw.io so that we do not have to mess around with paper and COVID cooties. And I want you guys to choose somebody that you don't think you would normally work with, and you can just send your diagram or your mirror drawing to them in maybe a shared Google Doc that you guys open up. And then I would say also, you guys go ahead and share that with me as well. So let's say Blake and Cooper decide to work together. So when Blake and Cooper are working on that, they will also give me editing access so that I can go in and I can help as well. And I think that would be really rad and really awesome. And then all we have to do is finish out our questions. Make sure we have all of our screenshots, including those mirror drawings along with the flowcharts. And then we are done with this assignment in 1.2. So whoop, whoop. Congratulations, kiddos. All right, nestlings. So let's go ye therefore and be nerdy and be super awesome. As always, I will catch you on the flip side and peace out.